Hi there, I'm glad to be here, and I'd like to tell you about some of our recent data-related projects at JetBrains. Let me briefly introduce myself. My name is Vasily. I work at JetBrains as a data scientist and product manager in Datalore team. JetBrains is a software vendor. We develop and sell IDEs and developer tools. And since we are at the data conference, you might have heard or use PyCharm. And regarding Datalore, Datalore is our recent product for data analysis and machine learning. You can easily create some predictive models, rich visualization, and share it with your colleagues, get some code review there, everything in cloud and for free. And my project called AI Intentions and Code Completion. So I'll guess all of you have heard a lot about AI in use and in the web, and I apologize for mentioning these two letters in my topic, but it's a good way to just to indicate the idea behind this, meaning to predict something based on the user's behavior patterns and content. So, and also when you give in a talk, it's like AI, when you're working on it, it's ML, and when you're thinking how to solve this problem, it's usually a linear algebra or statistics. So I hope you won't blame me for the two capital letters, and let's get started. My presentation is divided into two parts. First will be about intentions, and the second about code completions. Let's start from intentions. So the idea of the project was quite simple. Datalore supports intentions, which is basically a piece of code, some recommendation based on your previous cells or lines of code. And intentions cover a variety of actions, such as generating code. If you load your CSV, then you have intentions to drop an A, for example, in pandas. Or it could be some optimization suggestion. And the idea was to rank this list of intentions and determine the top list of intentions based on the previous lines of code. And the goal is to create a smart code helper and gather some interesting stats from the datasets. For sure, we faced several challenges during this project. The first one was about privacy. We cannot access the user's source code, and we cannot match the exact line of code with intention which were activated or invoking. And the second, we got the statistic about our usage, like events, and it's also anonymous, and it was quite tricky to match the activity of users with the intentions from this event data. So for reinforce our model, we gathered 6 million public Jupyter notebooks from the web. We filtered them out like a Python 2 version, or just empty or maybe very old notebooks. And we also use our internal data about usage with more than 1 million events with timestamps. And here's the example of the simple Jupyter notebook file with some metadata and cell structures in JSON. So before we get started to implement something and create predictive models, we get some insights from these 6 million notebooks. They're on the slide. So basically, some of the notebooks, like 2.6%, don't use Python at all. There are some Python-related Julia language, or some exotic ones like F#. And another interesting fact that more than 300,000 notebooks were with sensitive data, such as credentials, passwords, tokens, which is also quite a lot in that data group of 6 million notebooks. And also few distributions of some statistics. Here's like import stats, which shows that about 15% of users don't use import at all, and Well, the main case cover the figure with less than 10 imports per notebook. And the same for folder structure, which was interesting because about a third of users don't use any subfolders in their projects. Regarding technical stack, we use TensorFlow for training our models. By the way, PyCharm supports the new version of TensorFlow, fully supports it, and we use TensorFlow serving for production and for serving our models, and we use Flask to pre- and post-processing our datasets via an Nginx. So to implement our model of intentions, we use two standalone services. One service for processing data and another for predictions. And regarding prediction, so each action of the user were mapped to the vector, and then we use a LSTM model and map this feature with the probability of the next iteration. So the idea to get the list of top useful intentions based on the previous actions of user. So I can show you the scheme which is better represent the idea of the architecture. So it's like the two-way model where we have actions from the user's notebook, tokenize this data, and then make prediction using LSTM. And at the final step, we add some probabilities to get the final list with the top ranked intentions. And the next slide shows the simple demo of our model. So on the left side, it's like the old one without any kind of ML algorithms. And the new one is our AI intentions, where you can see the user load some CSV file with pandas, then set the target feature. And after that, with new model, you get the train and test split prevails over others. Whereas with the old one, you just get the list of intentions. So that was the idea of the AI intentions. And as a result, we get the 60% accuracy for top 1 intention and 92% for top 5, which is quite good, taking into account the fact that it's like the 5 options after you, let's say, upload your CSV file. The second part is about code completion. It's also a hot topic, and lots of companies like to get rid of data scientists or engineers with the AI algorithms. And for sure, there are lots of existing solutions of smart helpers and code completions. At JetBrains, we already have ML completion ranking, which you could activate in your settings in IntelliJ IDEA and PyCharm. There are many of them, like you name it, from where major vendors, but we at Datalore would like to create a specific code completion model, because Datalore work with some subset of Python, because it's about data analysis and machine learning. And we have a specific machine learning vocabulary. So, but we can also use the whole domain for pre-train our model. And also, where you work with Jupyter notebooks, you have the structure of cells, and this structure and sequences also might be used to get additional input features. So with this project, we also face some challenges, which are large variety of completion data and the classical imbalance of intentions data, because the vast majority of our users don't use intentions at all, unfortunately. So we have unbalanced problem, and we use oversampling to solve that. Concerning pipeline, so we are dealing with the notebooks, and at the first step we just merge, join all the cells and filter out markdowns, some images, and metadata from the Jupyter notebooks. Then we use byte pair encoder for data compression, and we use last and tokens with different variety to path the model for predictions the next token. We also try different models and different value of n for at this step. And on the last step, we just use the top k predictions to understand the list of probabilities for the next line of code or next piece of code. For model architecture, we use a transformer because it's like a state of the art for the last 2 years, especially for NLP problems. But we use only encoder blocks with positional embeddings in it. So, and the number of attention heads and size of blocks also vary. And to implement this model, we generate byte pair encoding, as I mentioned before, and we mapped it with like most frequent units, and then we trained our model using the unsupervised approach, where we have few tokens, and we predict the next one. And to show the result of our model, I have some simple example with our current proof of concept. As you can see, so sometimes it shows quite a good accuracy, but the idea that you type some string and get the output for your next function or command. So as a result, we have 57% top 1 accuracy, and moreover, it's only 200 milliseconds performance. So for the further improvement and further steps, because there's always space to improve your model, we plan to add into our dataset the runtime metadata as an additional feature, because it helps us to understand the consumption of each line, or also we can use this for additional loss function. And we can also plan to use domain-specific Python language to create new intentions for like the first project which I mentioned, and the idea was to find some patterns during the data science workflow to create a new intentions for Datalore. And also we plan to implement the evaluation metric into Datalore product to understand the real performance of our feature. And this code completion will be implemented in the coming update of the Datalore. So it's also a good time to mention my teammates, Adam from Boston and Vladimir from Moscow. So we are working on this project, and project relates to machine learning at Datalore. And the final slide is about references from which we got the inspiration to these projects. And for example, the second one, attention is all you need, is not about some personal development or mindfulness or happiness. It is just specifically about the neural nets transformer architecture. So that's basically it. Thank you for your attention.
All right. Thank you, Vasily. We have lots of time for questions. Any questions in the audience?
Thank you for the talk. And in regards to code completion, I have a question. Then maybe if nobody has a question, then I'll ask about AI intentions. But first, the code completion. So how how did you, what's the specific, like the details? Are you predicting like based on n previous characters, the next character, or is it a word based, like, or is there some rule based technique in there in order to alleviate the possible problems?
Right. So we use different number of words and symbols to create the prediction for the next one, and we try different like skipping window to create the prediction for the next line of code, and we just choose the one with the best performance.
First of all, thanks for the talk. And one thing I'm a bit confused about is when you talked about the class imbalance, did you like manually tag those, or how did you get the actual target intention really?
So as I mentioned, there were like the problem with unbalanced data, and for that we used like oversampling with synthesized data of intentions evoking, and we label these samples as intentions. So because for imbalance problem you have several approaches like undersampling and oversampling. So we choose oversampling because we gathered 6 million public Jupyter notebooks. Also we match them with our 1 million events of usage of our product, like the intentions events with timestamps. And this helps us to generate the additional classes for intentional and to get the balanced problem between classes.
Question down
here. I was wondering how much faster you think you can make it in the near future, because 200 milliseconds is already pretty fast, but still on the edge of real interactivity.
Right, thank you for that question. It's really depends on performance, because still with the current model we can make it faster, but with less accuracy. And also we have other limits, such as web-based product, because Datalore is in cloud. You don't need some local environment or your machine with lots of memory. So we stuck into that limits, and I think the threshold of 200 milliseconds is quite good for data science workflow, because you don't need to like to think fast when you write the next line of code. And we aim to do this figure for the next version.
You want to ask again?
So I joined 2 minutes later, so maybe you talked about it in the very beginning, but about these AI intentions, where do you get the ground truth on the intentions? Where does it come from?
So in Datalore we have intentions, like it's just code suggestions. And when the user press this button or like activate it, we collect all the data about these events, like the type of intention and the type of code which user generate. So we got this historical data and use it for train our model.
Anybody else? I have one more question. How did you determine that there were 300,000 notebooks with sensitive information?
Basically, we just count them. Using
but not by hand, right?
No, of course not. We use like a simple string mask with regular expressions to get the pattern of passwords and like the form of the regular sensitive data.
Right. Then, if there are no more questions, let's thank this. Oh, there is one. Sure.
How do you split the code of those many notebooks into blocks for suggestions and for training?
Oh, well, as I shown on this slide with the sample of Jupyter notebook, you can easily understand the sequence of cells, and you can filter them with some conditions. And after that, you can concatenate them and split by, let's say, by packages or libraries, depends on your goal.
Right. So if there are no more questions now, let's thank the speaker again. And